Hello everyone. Hello everyone. Welcome to the next lesson on module of DC circuit. In this, we are going to study the delta to star conversion and star to delta conversion, which requires oftenly in the network reduction circuits. So between point 1 and 2, the resistance is R12. Between 2 and 3, resistance is R23, and between 3 and 1, the resistance is R31 in delta network. The same equivalent resistance in the delta network between point 1, 2, and 3 is R1, R2, and R3. This delta is converted into star. I want to find out what will be the value of R1 in terms of this delta parameter, R2 in terms of delta parameter, R3 in terms of delta parameter. So let us calculate the resistance between point 1 and 2. So take this point 1 and this point 2. Here will observe that R31 and R23 is in series, as we are calculating between 1 and 2. R31 and R23 is in series, and this is parallel with R12. That is, R12 is in parallel with R31 and R23. So R12 into R23 plus R31, R12 plus R23 plus R31. Similarly, in star connected network between point 1 and 2, the resistance is R1 plus R2, that is R1 plus R2. So R1 plus R2 is equal to R12 in bracket R23 plus R31, R12 plus R23 plus R31. Similarly, between point 2 and 3, between point 2 and 3, R23 is in parallel with the series combination of R12 and R31. That is R23 into R12 plus R31 divided by R12 plus R23 plus R31. And in star connected network between 2 and 3, the resistance is R2 plus R3. Similarly, between point 3 and 1, R3 plus R1 is equal to R31 plus R1 into R12 plus R23 divided by R12 plus R23 plus R31. Okay, so subtracting this equation number 2, let this is equation number 1, this is equation number 2, and this is equation number 3. So subtracting the equation number 2, that is this equation, from this equation 3, that is R3 plus R1 minus this equation R2 plus R3. So what will happen? This R3 will get cancelled. It will remain R1 minus R2. Similar operation is done on the right hand side. That is this term minus this term. If we do this and the denominator is same, so we will get R31 R12 and R23 and R12. Why these two terms are cancelled? R31 and R23, and R23 and R31, they are opposite terms, so they will cancel. So here it will remain R12 is taken as a common, so in bracket remain R31 minus R23. Okay, as we get R1 minus R2, we will add this equation with the equation number 1. Equation number 1 is added with the R1 minus R2, so we'll get the value R2 will cancel. We'll get the value of 2R1 as 2R12 R31 divided by R12 plus R23 plus R31. Okay, so 2 will be cancelled on the both sides, so R1 is equal to R12 R31. So I want the value R1 will be equal to R12 R31 divided by sum of all resistance in delta, is R12 plus R23 plus R31. See here carefully, I want to calculate R1, which is here. So it is the form to remember this formula. It is very simple. Okay, I want this branch, so this branch is multiplication of two adjacent branches, so you can say two legs, that is R12 into R31 divided by sum of all resistance. So I will calculate R2 means the resistance which is here in star network, that is this resistance R2 is equal to R12 into R3, is multiplication of these two divided by sum of all resistance. Okay, and R3 multiplication of this, that is R23 and R31 divided by sum of all these resistances. So this is what delta to star conversion. Next we will see how to convert the star network into delta network. I have a star network, I want to convert into the delta network. We just calculate the formula of R1, R2 and R3. R1 is equal to R12 R31 divided by sum of all resistance. R2 is equal to R12 R23 divided by sum of all resistance. R3 is equal to R23 R31 divided by sum of all resistance. So let us multiply R1 with R2. So R1 and R2 is multiplied with each other. If I multiply this R1 and R2 with each other, so the in numerator R12 square will become R12 square R23 R31, in denominator R12 plus R23 plus R31 bracket square. Similarly, if I multiplied R2 R3, I will get this term. Similarly, if I multiply R3 with R1, I will get this term. Okay, adding all this term, that is R12 R1, R2, R2, R3 and R3, R1 are added with each other. If I add all this as each other, then I can take the common R12. So here R1, R2 plus R2, R3 plus R3, R1 is equal to, from all this denominator is same, so r1 plus r12 plus r23 plus r31 square. So here r12 r23 r31 in bracket r12 plus r23 plus r31. So this one term from the numerator and one term from the denominator will cancel. This r1, this will cancel with the one term of the denominator. So in numerator what will remain? R12 r23 r31 divided by r12 plus r23 plus r31. Dividing all this by r1, suppose dividing this with the r1, that is r1 value, this is r1. If we divide all this with the r1, so r12 plus r1 r2 plus r2 r3 plus r3 r1 divided by r1 is equal to this term divided by so it will remain r12 plus r23 plus r31 r12 into r23. So this term and this term will cancel. R12 will cancel with r12, r31 will cancel with the r31. So what will remain? R23. R23 is equal to, so here what will remain? R23. So R23 is equal to R1 R2 plus R2 R3 plus R3 R1 divided by R1. Or if I divide it by R1, so R1 R1 will be get cancelled. So it is R2 plus R3 plus R2 R3 divided by R1. Similarly, R12 is equal to R1 plus R2, R1 R2 divided by R3, and R31 is equal to R3 plus R1, R3 R1 divided by R2. It's very simple for the calculations. So if I want to calculate this term, okay, if I want to calculate this term, how I can do? I want to calculate R12, so R12 is equal to R1 plus R2 plus multiplication of this, that is R1 R2 divided by opposite resistance. See, the formula is very simple. What I want? R12, so R12, this term is equal to sum of R1 plus R2 plus R1 into R2 divided by R3. Okay, R1 plus R2 plus R1 R2 divided by R3, that is R3, which is opposite resistance over here. So this is about what? Star to delta conversion. In next lecture we'll see about the Kirchhoff's law.